What if you want a car that looks fast but is actually slow in a straight line? You can get a Toyota 86. But that's not what these cars are trying to achieve. To the trained eye, these are the best rear-wheel drive cars to start out with on a racetrack. Why is this? Very predictable handling, a lightweight but rigid chassis that gives the car a very nimble feel through the twisties, a very low center of gravity, a high revving, albeit agricultural sounding powertrain that takes mods well, and tyres which make it very playful. In this Automotive X-Ray, we'll be looking at each of these reasons to find out why these are seriously the best bang for buck rear-wheel drive cars for motorsports applications. With that being said, let's begin. Firstly, the wheelbase on this car is quite short at 25cm, so it rotates pretty well, but it's not too short. Look at the Mazda MX-5 for example. The NC, which is set to be a boat, has a wheelbase of 2330mm. That's 240mm shorter, which is almost the size of a 30cm ruler. Why do you think these aren't very popular drift cars from the factory? This is due to a very short wheelbase and the MX-5 being front mid-engined, which makes the car very quick to rotate, a trait that can make it quite snappy or spinny at the limit. What's the point I'm making here? When you have a car that has a slightly longer wheelbase for a sports car like the 86, to oversteer is quite progressive and stable instead of being very sharp, as when the rear wants to let go, especially on those lower grip tyres, which we'll harp on in the business end of the video, you have time to correct the oversteer to the point where you can even hold a pretty nice skid. But this isn't the only reason why, as we'll dive deeper at the end of this section to touch on the 86's suspension geometry. But the wheelbase doesn't just tell the full story. Let's use the MX-5 as an example again. From stock, its suspension is soft and gives a lot of body roll, which is actually a great thing when learning weight transfer, but not so good if you want to push hard with confidence through every corner instead of waiting 3 business days for the car to settle again. This is why the 86's front spring rates aren't too stiff. They're just soft enough at 23 newtons per millimeter to allow for the right amount of body roll on initial turning. But with the McPherson strut front suspension that the 86 has, you get less camber gain, which can mean less grip and traction, as the 86 only has negative 1.3 degrees of camber from factory, making the 86 more prone to understeer at the limit. Making the weight distribution being slightly front biased at 53/47 also gives it an understeer bias, and for drivers new to wheel-wheel drive, that's a lot easier to manage on the track. And if you want more grip, you can always run camber bolts and plates, and even 200 tread wear tyres if you want that super sharp driving feel later on. Speaking of camber, the rear is much better with negative 2.4 degrees of camber, as it runs a double wishbone setup. With double wishbones, the top wishbone is shorter than the other, and when that suspension is compressed, you get camber gain, meaning more grip and traction through that corner. Now, if you want to easily provoke power oversteer, this car allows you to do that fairly well, as the anti-squat value is 64%, meaning they're actually pretty good drift cars from the factory. Let's break this down a bit more. At 64%, the car resists a fair amount of squat, but not entirely, as the rear can compress slightly under acceleration. Now, with the small amount of body roll, the tyres gradually lose grip, making the oversteer very predictable to handle, and that's why they're much easier to drift compared to an MX-5. Anyway, let's now move on to another reason why the 86 handles so well, a lightweight but rigid chassis. Why does the chassis need high torsional rigidity? Well, the more rigid it is, the less the chassis will twist and deform under heavy G-forces in corners. What this means is that all 4 wheels will evenly distribute load to the ground and increase grip. With this in mind, one of the biggest goals of developing the 86 was to ensure it was as lightweight as possible to give you that nimble feeling in the corners. And I have achieved this with clever manufacturing choices like fabricating the bonnet in sheet aluminum to keep the weight down at around 1,239 kilos, which is less than a Honda S2000, despite having a much longer wheelbase and even 2 extra seats, although they are useless for most adults. Now, in terms of body rigidity, the 86 chassis is much better from the factory for track work than the MX-5. If you watch an MX-5 on track, especially the older gens, they often roll a lot and can be pretty loose. This is not just due to the soft suspension, but also due to the chassis being quite flimsy, especially in the NA and NB, where you had to add mods like a roll bar, frog arms and frame rails to stiffen the chassis if you wanted to add more power. Even the ND MX-5, which was released 3 years after the 86, has 55% less structural rigidity than the 86, with the 86 having a whopping 20,000 Nm per degrees. How were they able to do this? First up, they used 980 MPa high tensile steel for areas such as the roof side rails, front header and center pillar reinforcement, and 1500 MPa grade hot press steel was used for the roof center reinforcement. The adoption of a pagoda roof form gave the 86 extra torsional stiffness to the structure, whilst allowing it to be fabricated in steel just 0.65mm thick to minimize weight. With that, let's now move on to a fundamental part of why the 86 handles so well, its low center of gravity. One of the reasons why the 86 has such great handling, especially for dummies new to rear wheel drive, is due to a low center of gravity. So this begs the question, why do sports cars have a low center of gravity? It's the same story with how the 86's suspension was designed from the factory, to reduce excess weight transfer. Now, you might think the 86's low center of gravity is just because of the engine and how it is placed, but it's not that simple. Whilst the boxer engine does lower the center of gravity by a bit, the engine being a boxer design isn't actually the main reason why it's so low. There were actually quite a few changes made so that the engine could be placed very low, such as using a front mount air intake layout, a low intake manifold, and the exhaust system being placed quite low. Even the oil pan design was thinned out to lower the engine center of gravity. But it's not just the engine that allows the 86 to have such a low center of gravity at 46 cm, which by the way is 4mm lower than the Honda S2000. One of the most interesting choices Toyota made was reverse positioning the L-shaped front lower suspension arm to allow the engine to be mounted as low and as close to the center of the vehicle as possible. Speaking of suspension, coil springs and strut mounts were positioned as low as possible to lower the center of gravity. All these changes meant that 86 had a driver hit point of 40 cm, which is the lowest of any Toyota production vehicle at the time. Now we've talked about how they've been able to mount the engine that low, let's actually talk about the powertrain itself. Okay, let's address the elephant in the room. This FA20D engine is gutless from stock, despite making almost 100 horsepower per litre from the get-go, as it produced 197 horsepower at 7,000 RPM and 205 Nm of torque at 6,400 RPM. The way the power is delivered is a bit uninspiring to say the least. Yes, it revs out to 7,400 RPM, which is still a pretty great thing, but it sounds like it's riffing in pain, rather than singing its way to its red line. To be honest, it's the same story with the new GR86-BRZ, especially with that fake engine sound. I don't know, might be just spots of things, unless you add mods to make it sound better of course. But unlike the GR86-BRZ, there's a dreaded enemy you feel for half a second or so when revving this engine out. It's what we call the torque dip. Why does this happen? To get this car to make the power it does, you can't just rely on port injection. So Toyota used a D4S dual injection system, where port injection is used at low RPMs to clean the intake valves and avoid carbon buildup, and at low RPMs, direct injection is used. The problem is, the transition between port and direct injection wasn't smooth enough from the factory, which causes the torque dip. On the other hand, this D4S design is a key reason the FA20 responds so well to minor bolt-ons like headers and a tune to deal with the torque dip issue. This is as running just port injection like older NA engines would mean running into issues with ignition and knock. But the torque dip's not the only issue with this engine. On track, the engine can even starve itself of oil due to aggressive cornering. But here's the thing, most beginner drivers when starting out won't corner that hard anyway on track. Otherwise, they're gonna bin it instead of blowing the engine up. Before we begin the last section, let's quickly go over the gearbox. Whilst the 6-speed auto is pretty overbuilt and reliable, we're gonna focus on what makes this car so engaging to drive. A 6-speed manual. Whilst the gear ratios are pretty short, especially with the 86 having a Torsen LSD with a final drive ratio of 4.1, the reason why I feel so engaging is due to a short throw lever with triple cone synchro mesh being used for first, second and third gears. And with that, let's talk about why this car can be so playful in the corners. To make the 86 a very easy car to control oversteer and understeering, Toyota has fitted either 16-inch or 17-inch wheels with tyres which are basically from a Prius. These tyres, especially the 16 inches, don't have much outright grip, making it very playful and fun to slide around even on the street. Combine that with what many owners dub as some of the best steering feel from an electric rack, and you get a car that is in a way a better learner's tool than the second gen, which has a lot more overall grip with the 18-inch Michelin Pilot Sport Force. The torque dip also provides the beginner an interesting challenge to manage the power bend on track and autocross, unlike the GR86, which seems to have gobs of power and torque everywhere. Let's now head into the concluding remarks. Overall, what are my thoughts on the Toyota 86? Honestly, I wasn't a big fan of this platform at first, but when you look deeper, this is probably the best starter rear-wheel drive platform for the money. Whilst the RX-8 can also be had for a very cheap price nowadays, while sounding way better and having a chassis that's 33% stiffer than the 86, the 86 has a much bigger aftermarket and is much easier to maintain, making it the perfect choice for beginners. If you've got any other cars you want us to conduct an automotive X-ray on, let us know in the comments. Thank you so much for the support already with the previous videos. Let's keep this up so we can continue to make this a regular thing on YouTube, where we really break down and dissect some of the best cars ever. Much love to you all, and I'll see you in a bit.